Hey everyone, today is 11th August 2024 and we're going to solve the problem of the day, which is minimum number of days to disconnect island. So we're given an m by n binary grid where 1 represent land and 0 represent water. And an island is a maximal 4 directionally connected group. 4 directions means left, right, up and down. And the grid is said to be connected if we have exactly one island, otherwise it's disconnected. Now in one day we are allowed to change any single cell into a water cell and return the minimum number of days to disconnect the grid. So the examples given here are not sufficient to understand the complete problem. So I'll show example like this. So first intuition which I had was I'll count the cost or basically the benefit of converting one cell into or one land into water. So how did I do that was I counted the number of lands one land was enclosed by. So as you can see here, one land was enclosed by this was enclosed by two. This was also so in this case everyone was enclosed by two. So you can choose any land at random and make the adjacent ones water and you'll get a solution. Then I went on to this. So this is basically your worst case where everything is land. But when even when everything is land, actually, if you see here, everything is land is the worst case. We can see here that making these two or basically any corner piece, we can detach it by in two moves. So I concluded that our answer can at max be two. Since it was completely filled with land, still we managed to make it two islands in two moves. Then our answer is max two. So since we want to return the minimum number of days, and answer is at max 2, which means its answer will be either 1 or either 2. So when will answer be 1? So I'll show that. So let's say in this grid, you just need to delete this and you will have your answer. So only one day is the answer here. So how will we find that in for any particular example? How will we find that the answer is 1 or not? So do that, we will go over each of the cells and check whether it's a land. If it is a land, we will going to convert that to water for just for this instance and then run our counting of number of islands. So basically we are checking whether deleting the particular or converting the particular land to water will disconnect our grid or not. If it does disconnect, we can simply return 1 because only one cell we need to convert to get disconnected grid. So just like this, if you go over each of them, these will not return true because they are not disconnecting. Only for this one, when we convert it to water, we'll find out that the number of islands become 2 and we'll return 1 in that case. So let's code this solution. Okay. So first thing you need to know is you have to make a deep copy of the grid. A simple copy won't work since that will uh, manipulate the grid in place. Now suppose we can find the number of islands somehow. I'll get into that later, but first what we'll check is first in the given grid, we will get the number of islands for that and check if it's greater than 1. So if the given example already is disconnected and island double equal to 0 is also disconnected, which basically means everything is water, that's also considered as disconnected. So we'll return 0, we don't have to make any manipulations. Apart from that, answer could be 1 or 2 only. So 2 is our fallback. So how will we find it if it's 1? We'll go over each position, and if it is a land position, we'll create a copy of the grid without that piece of land. So just like I told you, we will take this grid, create a deep copy of it, and suppose our iterator is here, we'll convert it to water and now apply our algorithm of counting number of islands on it. So once we have the count, we'll check if it's greater than 1, which basically means we have disconnected, and also island is 0, then also we have disconnected. So we can return 1. We only need to convert one cell to water and we are done. If no such cell is found, like if in this case you go about it, if you make this cell into water, then also it is the output of number of islands will not be greater than 1 or 0. So in such a case where you have gone through, you have exhausted the complete grid and you have not found such a case where you, after removing a piece of land, it becomes disconnected, then at the end you return true 2, because we know that even in the worst case in 2 days we can convert it. So yeah, that's our solution. And if you want to see the number of islands, it's pretty easy. You have to go over the grid, and if it's a land, we'll apply DFS on it, and this DFS will do something which is basically marking the land parts as visited. So it makes sure that once the DFS is run on a part, so if I run the DFS here, it will run something like, maybe I go right first. So to go right, then I go down. Okay, then right is nothing, then I go down. Then we hit the water, so then we go left. Okay, then down. Right is already visited. Down is, then we go left. Then for right is already visited. Left, then we go up. Then we go right. And yeah, basically everything is visited. And this, we mark this complete as a visited. Let's say with purple. So these are visited ones. Now I'll iterate over this. So I'll go to this position. This is also visited. So I could just continue, and I'll come to here, which is a land which is not visited. Then continue my DFS, and similarly it will create this landmass and make it some other number so we know it's visited. And as many times we can do that, we can say that we have found a new island, so I increment count. And DFS is pretty simple. We just check if we are out of bound, we return. If we have already visited, so I'm marking visited by -1. So if it's either water or visited, we return. Otherwise, we mark the particular land as visited and go to its neighbors, which are basically down or right, left, and up. So the time complexity and space complexity for this will be the time complexity. If we have an m by n grid, we are basically going over the entire grid the number of times there is a land. So in this is the worst case. So for this particular piece, we'll go over the entire m by n grid. Similarly for this, so we have m by n land and m by n times we are going over it. So we'll have m square by n square time complexity, and space complexity will be m by n since we are creating a copy of the grid. So that was the solution. It beats 41% in terms of time and 93% in terms of memory. So I guess it's pretty efficient. There can be some optimizations here, but I was not able to find them. So thank you.